Okay, before we get started, I need to remind you about the Pythagorean Theorem. Right? Usually when I say the Pythagorean Theorem, somebody says, oh yes, I know what that is. And they're thinking of A and B and C. And they will say something like A squared plus B squared equals C squared. And that's true. If you have a right triangle, the Pythagorean theorem says leg squared plus leg squared will equal the hypotenuse squared. So what that means to you and me is if you're ever given two sides of a triangle, say if I know that this is 12 and this is 13, you should always be able to find the third side of the triangle using the Pythagorean theorem. Alright, so if you have two sides, you should be able to find the third side. So in this case, if I have x and 12 and 13 and I want to know what the missing side is, I would say x squared plus 12 squared should equal 13 squared. That means x squared, that means x squared plus 144 should equal 169. Subtracting 144 from both sides, that means x squared should equal 25. And taking the square root of both sides, that means x is going to be 5. So this side would be 5. So the Pythagorean theorem, if you're given two sides of a right triangle, you should always be able to find the missing side. Here are a couple things that we learned today. We learned what a perpendicular bisector was. If you understand what these two words mean separately, then you'll understand what they mean together. Perpendicular means forming 90 degrees, and bisector means cutting something in half. So say if I want to talk about the perpendicular bisector of segment CB. Okay, so that means focus on segment CB with me for a minute. Okay, so here is segment CB in orange. If I want to make the perpendicular bisector of segment CB, I need a line that is going to be 90 degrees to this, that's perpendicular, and it has to cut it exactly in half, and then that would make it a bisector. So let me concentrate on cutting it in half first. Let's see, let me make a tiny little circle, my friends. Okay, so here's a little circle. Let's say I'm trying to get this right about at the midpoint. I think that's pretty close to the midpoint. Okay, so if that's the midpoint, if I put a line through this, it will be the bisector of segment CB. So then all I have to do is make sure that it's perpendicular. So let me give it a shot. Alright, so I'm going to start from here because I know it has to go through here. So this is me trying to form a perpendicular line. I think I'm doing okay, but who knows really. Okay, so I gave it my best shot. Let me make it a little bigger. Okay, so I think that I have just made something very close to the perpendicular bisector of CB. If it is perpendicular, like I wanted it to be, then it will make a 90-degree angle like that. If it is a bisector, then this side will equal this side because it should be cutting it in half. That's what a perpendicular bisector is. Now, we learned that if we make more than one perpendicular bisector in a triangle, they will all meet at the same point, and that point is called the circumcenter. So the circumcenter is where all of the perpendicular bisectors meet. It's one way of just talking about the center of a triangle. We will talk about 4 ways to talk about the center of a triangle, but circumcenter is the first one, and it's where all the perpendicular bisectors meet. So if you look carefully, all of these pink lines are perpendicular bisectors. Look at each one. This is perpendicular, and it's cutting this side in half. This line is perpendicular, 90 degrees, and it's cutting side BC in half. And this pink line right here, look, it's perpendicular, and it's cutting side BA in half. All 3 of these pink lines are perpendicular bisectors, and you notice that they all meet at one spot. This spot where they all meet is the circumcenter. Okay? So that is how you find the circumcenter. But that is not the important property of a circumcenter. Here is the property that you need to know for a circumcenter. Okay? The circumcenter is equally distant to the vertices, which are the corners of the triangle. Okay? In other words, watch this. If I were to measure the distance from the circumcenter to vertex A, all right? I just want this to show up easily. So there's one distance to one of the vertex. And then if I were to also measure the distance from the circumcenter to vertex B, what do you think I would find if I measured these 2 distances? These 2 distances should be the same. Okay? That's what I mean when I say the circumcenter is equally distant to the vertices. And why not? Let's finish it up. If I also measured the distance from the circumcenter out to the 3rd vertex, C, once again, that should be the same distance. Okay, so this is the main property of a circumcenter that I want you to know. So I wanted you to know how we find the circumcenter. We find it by building perpendicular bisectors and seeing where they meet. But what really matters about a circumcenter is the circumcenter will be the same distance to every corner, to every vertex in the triangle. That's why we call it a center of the triangle, because if it's the same distance to all the corners, in some sense it is in the middle. Okay, now we should be ready to do example 4. We're supposed to find all of these lengths. Now, thing number 1, they did not mention whether or not this point G was the circumcenter. But we should know if it's the circumcenter or not. Is point G the circumcenter of the triangle? Well, how do we build a circumcenter? We build the circumcenter by making perpendicular bisectors. So look at line GE for a second that I've drawn here in pink. Is this a perpendicular bisector for segment BC? Hopefully you can see, yes, this is a perpendicular bisector. It's perpendicular, 90 degrees. It's a bisector. These 2 pieces are equal, so it goes right through the middle. So this pink line is a perpendicular bisector. Is this pink line, DG, is this a perpendicular bisector? Well, yes it is. It is also perpendicular. It is also a bisector, cutting its side AB in half. What about this last one, FG? Is this a perpendicular bisector? And yes, once again, this is a perpendicular bisector. You see it's perpendicular and it splits AC in half. Look at the markings. So, these pink lines are all perpendicular bisectors. So, when perpendicular bisectors meet, they do meet at the circumcenter. So that tells us that G is the circumcenter. Okay? So they don't have to tell us it's the circumcenter. If we see a bunch of perpendicular bisectors all coming together, then we know that it is the circumcenter. Now, what is the special property of a circumcenter? Let's see, can I look back? The special property of a circumcenter is it is equally distant to the vertices. That means from the circumcenter to each vertex, each corner of the triangle should be the same length. So let's apply this to example 4 here, if I can find it. Okay, so if this is the circumcenter, and we've just decided that it is, then it should be equally distant to the vertices. So the distance from G to A should be the same as the distance from G to B. It should be the same as the distance from G to C. That is the special property of the circumcenter. It is equally distant to the vertices, the corners. So all these 3 red lines should be equal. That means right now you should be able to tell me the length of segment GC. Because if I know one of these 3, I should know all of them. So how long is GC, you guys? Hopefully you were saying that GC was going to be 15. How did I know that? Because of this. AG is 15, so that means all of them are 15. That means BG is also 15. Alright, the distance to the vertices should be all the same. So that gives me 3 right there. Now, so let's mark what do I have? Okay, GC is 15. That's this one. So this is 15. Okay, GB, did they ask me that? Yeah, that's right here. This is also 15. Okay, now to find anything else, we're going to have to use the Pythagorean Theorem. Okay, all over the place, we can use the Pythagorean Theorem to solve these problems. For example, say if I want to find AF, which is coming up right here, AF. AF is down here, but I want you to focus on the triangle that I'm about to color in blue right now. It's a very slow moving triangle. Let me move it up. Okay, look at this triangle right here. I should be able to do the Pythagorean Theorem, shouldn't I? So looking at this blue triangle, notice that we have 2 sides of this triangle given. Notice that it's a right triangle. You can tell because of the box right here. So we have a right triangle, we have 2 sides given, so we should be able to find the 3rd side, which is AF. So let's do that. Just to make it easier to see, whoops, I moved the wrong thing. Just to make it easier to see, I'm going to move this blue triangle off to the side. But if you can follow this with me now, the hypotenuse, like right here, see, this is my 90-degree angle. This hypotenuse was 15. This leg over here was your 6 that you see right there. All right, see where all these things are coming from? And your AF, okay, I'll just call that X for right now. So do you see how it all matches? The 6, the 15, AF is x. So if I solve this for x, then I'm finding AF, Pythagorean Theorem. So a squared plus b squared equals c squared. So I'm just going to go x squared plus 6 squared equals 15 squared. So that's going to be x squared plus 36 equals 225. Then I'm just going to subtract 36 from both sides. So that's going to give me x squared equals 189. So now if I just take the square root of both sides, square root, my TI-30XS multi-view is going to give me 3 radical 21. So that is AF. So I can just put 3 square root of 21 just like that. What else are they asking me for? Let's see. We need CB. Okay, CB. We should know that right now. That shouldn't take any work, so let's get that out of the way. If the distance from B to E is 12, guess what the distance from B to C is going to be? Hopefully you were thinking 24. E is the midpoint. So if this is 12, then that means this over here has to be 12. So the total here has got to be 24. So CB should be 24. So that just leaves EC. Oh, that's just, okay. EC is also 12 for the same reason we just talked about. Midpoint 12, 12. EC is 12. Okay, so we had to do a little Pythagorean theorem. We had to recognize the property of a circumcenter. It's going to be equally distant to the vertices. That's how we got all these 15s. Midpoint, that's how you do that. So that's example 4. Okay. Example 5, kind of the same thing. Let's see, ignore these answers up here. Pretend like they are not there. In fact, maybe I'll move them away. Okay, O is the circumcenter of the triangle. The perpendicular bisectors are dashed. Okay, so just like on the previous problem, O is the circumcenter. So that means it should be equally distant to all of the vertices. So if I know one of them, I should know all of them. So because all 3 of these lines should be the same length, equidistant to the vertices. That is the special property of a circumcenter. So since we know that ON is 26.8, that means OM will be 26.8 and OP is 26.8. Alright, I'm just going to write this in here by hand. Okay, so that means this is 26.8 and this is 26.8. Okay, are those any of my answers? See, MO, did they ask me for that? Yes. That's why this is 26.8. OP, did they ask me for that? Yes, that is also 26.8. So we got that just because the circumcenter is equally distant to the vertices. Now, what else do we need? NQ. Oh, that's an easy one. NQ is this distance from here to here, obviously. What is that going to be? Well, look right here. This is 20. This is supposed to be a perpendicular bisector. So that means that these two sides should be the same. So if this is 20, then this is also going to be 20. So QN should be 20. What's next? Let's see, MP. Well, if this is the midpoint, then if MS is 22, then SP should also be 22. Am I right? So if both of those are 22, then what's going to be the distance from M to P? Well, it's going to be 44. One more. OR. OR. Well, my friends, for OR, we're going to have to actually do some work. We need to do the Pythagorean Theorem. So look at this triangle ORN. Look at this little triangle over here. Let me highlight it better. Alright, so just zooming in on this triangle so you can see it a little bit better. Okay, so this little blue triangle right here is a right triangle. Notice that we have two sides of this triangle given. We've got the 26 and the 26.8. OR is what we're supposed to find, the missing side. I feel like changing colors. Let's go with purple. So we are supposed to find this side right here, which I will call X. This is a leg. 26.8 is the hypotenuse. So a squared plus b squared equals c squared. Leg squared plus leg squared equals hypotenuse squared. So this equation should go like this. X squared plus 26 squared should equal 26.8 squared. If we solve this, then we'll have it. So this is going to give me x squared plus 676 equals 718.24. Let's just subtract 676 from both sides. So that's going to give me x squared is equal to 42.24. Now it's time to take the square root of both sides. Square root, square root. So that's going to give me x equals 6.499. Basically, that's going to be 6.5. Okay, so that should be my OR. It's approximately 6.5. Okay, that is how you do example 5.